Good day, everyone. We are MRV Quantity Surveyors, and we would like to introduce you to our case study for the Civil Engineering Assignment 1. We've done this in order to become familiar with the civil engineering work, specifically with the use of the SANS1200 C and D documents, which involve site clearance and earthworks on civil engineering projects. Fraser and I will be presenting today on behalf of Zaid and Fadil, and I would now like to hand over to Fraser, who will introduce our case study.
The case study was done on the Cengane Dam as a part of the Upper Kulunga Regional Water Supply Scheme. This is in the rural Eastern Cape. The dam had an estimated capacity of 360,000 kiloliters. And the construction was done between April 2012 to September 2013. The original completion date was supposed to be June 2013, however this was extended as a result of poor program management, among other things. It's located in Qumbu, which is about 60 kilometers north of Mthatha. The project comprised of a 17-meter high earth embankment dam with a 21-meter wide concrete lined spillway. There were three zones: the core, the upstream, and the downstream. The role players for this project was OR Tambo District Municipality as the client. Norland Construction were the principal contractor, with Ezel Frankie, East Coast Blasting, and Zaula Construction being the subcontractors. The project engineer was HHO Africa Infrastructure Engineers. There were 7 main stages in the scope of the works. Firstly, river diversion, then foundation preparation, grouting, the construction of the earth embankment, the construction of the outlook works, then the spillway, and the filter dams.
The site clearance on the site first involved a soil investigation. It was found that the soil consisted mainly of soft black silt, which was on the rock bed. There was also a large clay content of between 40 and 57%. Large dolerite boulders were also found on the site, and the site was found to have a very high moisture content. The scope of the works in clearing the site involved firstly stripping the topsoil. Some of it was carted off of site, and another portion of it was then reused on the site. The cut-off zone was then cleared. This was done in order to expose the rock surface, the rock bed, upon which the dam could be constructed. The black silt in the stream bed was then removed, along with the boulders and the exposed surfaces on the outskirts of the dam were then compacted by a pad foot roller. There's the SANS1200C document, which is the specification provided by SANS for the site clearance of civil engineering projects. However, this was not applied on our case study. The construction was of a dam, and therefore the SANS1200 document, the DE document, was used, as this is the document for the construction of small dams. Within this document, there is a section that is specifically on site clearance for small earth dams, and therefore this has been used instead of SANS 1200C. Differences between the SANS 1200C and 1200DE documents is that C does not allow for the extra over for removing boulders, whereas the DE document does. Site clearance in the C document is measured in hectares, meters, or kilometers, whereas the DE document only measures it in square meters or hectares. Topsoil removal in the C document can only be measured in cubic meters, whereas in the DE document it can be measured in square meters or cubic meters. And in the C document, the material disposal is clearly defined, whereas in the DE document it is not. Site clearance was evaluated using Section B site clearance bill that was provided to us. It was found that the site clearance was measured in square meters, which has been done according to clause 8.3.1.1. No trees on the site were found to be greater than 1 meter girth, and therefore they were not required to be measured. Boulders were found to be smaller than 0.15 meters cubed, and therefore the clause of 8.3.1.3 was applicable due to these boulders not exceeding that size. The basin clearance was measured in hectares, which was stipulated by the document, and it was also done accordingly. And finally, the removal of the topsoil was done in square meters, which has been done in accordance to clause 8.3.2.
For the earthwork section, we went through soil investigation, scope of the works, method of the works, and the plant used. The soil was found to have the higher levels of sandy soil with clay found deeper. There were also rock layers at varying depths, and the rocks contained fissures and irregularities. The scope of the works included restricted excavations, construction of the dam wall, construction of the spillway area, and disposing of unusable material. The method of the works included TLB and hand excavation, placement and compaction of materials, placement and spreading of materials, and cutting to form the slope. The plant used were TLB excavators, bulldozers, a dump truck, and pad foot roller. In this image, we can see the different earth layers. You can see the rocks as well as the more sandy soil towards the top, and the clay, the darker clay material towards the bottom. The gray area in the middle of the image is the grouting of the fissures that were in the rocks to create a watertight base for the dam.
There's the SANS1200C document, which is the specification provided by SANS for the site clearance of civil engineering projects. However, this was not applied on our case study. The construction was of a dam, and therefore the SANS 1200 document, the DE document, was used, as this is the document for the construction of small dams. Within this document, there is a section that is specifically on site clearance for small earth dams, and therefore this has been used instead of SANS 1200.
The evaluation of the excavations of the earthworks bill are as follows. As clause 3 specifies, the rate for excavations shall cover the cost of excavating in material of all types, including dumping, spreading, and trimming. All excavations were measured in accordance with clause 8.3.3. The work items were separated into core trench, spillway, pipe trenches, and outlet works. Cubic meter measurements were used throughout for all the items. Extra items were measured for difficult materials such as intermediate ore and hard rock. Depth increments were unknown for the excavation of pipe trenches. This bill includes the measurement of all material that forms the embankment to the dam. E1 to E3 measured in accordance with clause 8.3.4, which involves the preparation of the exposed core trench. Items E4 and E7 through E13 are included in SANS1200 DE under clause 8.3.5, which includes the measurement of all material that is to form the embankment. The unit required for the measurement of item E22 is supposed to be in linear meters as per clause 8.3.6. This item, the trow drain, has however been measured in cubic meters, and the linear length is provided in the description.
Concluding our presentation, our main outcome was the difficulty in obtaining project information. We found that a lot of engineers kept their information very confidential, and we were very grateful to obtain information on this case study. We found that the comparison to the SANS documents were quite straightforward, where the case study used or followed the measurement requirements quite closely. An interesting find was the use of SANS1200 DE for site clearance as opposed to using SANS-C, and this allowed us to gain a better understanding of the documents and their differences. And yeah, overall the assignment provided us with a much greater understanding of the SANS1200 C&D documents and the use of SANS overall as a measurement guide for civil engineering projects. Questions, please feel free to email myself, Courtney Mayer, at the email address found below.